Continue review session 51. Blank are the most common type of equipment susceptible to carburization in the refining industry. Oh man, I don't even know. Heat exchangers, maybe? C. Heater tubes are the most common type of equipment susceptible to carburation in the refining industry. 52. Okay. Different organisms thrive on different nutrients, including organic substances. Sulfur, H2S, and organic substances, hydrocarbons, organic acids. In addition, all organisms require a source of carbon, nitrogen, and what for growth? Phosphorus, or is it oxygen? Carbon, nitrogen. Okay, I think it's phosphorus. D. Because anaerobic organisms don't need oxygen, so they always need phosphorus. 53. In design and fabrication, it is advisable to avoid sharp changes in cross sections, such as short radius, fillets, or undercut that can give rise to what? Long seam welds are particularly susceptible to reheat cracking due to mismatch caused by fit up problems. Stress concentrations. The most important factors affecting graphization are the chemistry, stress, temperature, and looks like time at exposure, maybe? B. Time at exposure. Creep damage is found in high temperature equipment operating above the maybe creep range. Fired heater tubes and components, Cadillac reactors, FCC reactors, and FCC fractionators and regenerating turns all operate in or near this range. Is it creep range? Yes, creep range. Amine stress corrosion cracking is most often associated with lean amine service. The pure alkylamine does not cause cracking. Cracking in rich amine service is often most associated with what problems? Wet H2S, maybe? I'm not sure. Yeah, wet H2S. The loss in strength from spheroidization, softening, is usually accompanied by a what inductility, which allows for deformation at stress concentrations. Okay, loss in strength. Usually you're going to have a decrease in ductility. Or increase, sorry. That's the inverse relationship. So if something gets strong, increase in ductility. Okay, it's increase. I have to read over that. Which of the following materials is not susceptible to high temperature hydrogen attack? I think all those are susceptible. They all are. 3 series SS, 5 chrome 1 moly, 9 chrome 1 moly. Which of the following materials are susceptible to creep damage? I think they all are as well. D. Carbon steel, stainless steel, and low alloy steel can all suffer creep damage. High temperature hydrogen attack results from exposure to hydrogen at elevated temperatures and pressures. The hydrogen reacts with what in steel to produce what, which cannot diffuse through the steel. The loss of carbides caused in an overall loss in strength. Hydrogen reacts with, I think it's the carbides, and produces, I think it's methane, maybe? Or maybe it's oxygen, I don't know. C. Carbides, and it produces methane. That can be fused. Ferritic stainless steels are usually not used in what applications? Pressure boundary. I remember that. Stress ruptures are characterized by what failures and are usually accompanied by thinning at the fractured surface? Fish mouth. With hydrofluoric acid corrosion rates increase with what temperatures and what HF concentration? Hydric fluoric acid increase with increasing temperatures and increasing hydrofluoric concentrations. Nope. Increasing and decreasing. Okay, hydrofluoric acid corrosion. Corrosion rates increase with increasing temperatures and decreasing hydrofluoric concentration. To look at that one too. Which of the following materials is susceptible to CO2 corrosion? Carbon steel, stainless steel, or duplex stainless? I want to say carbon steel. Carbon steel. Steel hardness and stress are critical factors in causing hydrogen stress cracking. I want to say alloy composition or strength. I'm not sure. I want a strength. C, strength. Okay. If the BHN is 400 to 500, it may indicate hydrating. B. Okay. The graphitization rate. What with increasing temperature? It increases. Definitely. The level of creep damage is a function of the material and the coincident blank levels at which creep deformation occurs. Temperature, basically, and temperature and stress, I believe. C. Titanium should not be used in known hydrating surfaces such as, I want to say, amine and sour water, but I may be wrong. Yes, amine and sour water. Convert these temperatures 156C and 450F. So if I'm converting the C, see, that's off the top of my head. Let's see if we make sense. I know it's like something like 9/5 plus 32. So, just eyeballing it. They all look kind of close together. Oh, I want to say D almost, but we'll see. C, 312 and 232. That's a kind of a bullshit question, but I'll just. Which of the following alkylamine systems is the most aggressive in causing amine corrosion? Most aggressive in amine corrosion. I know it's one of the M's. MEA maybe? A? Let's give this life log. Blank is a loss in toughness due to a metallurgical change that can occur in alloys containing a ferrite phase as a result of exposure to temperature range 600 to 1000. That sounds like 885 embrittlement. Because, the kind of temperature right there in the middle. Hydrochloric acid corrosion is a general and localized corrosion and is very aggressive to most common materials of construction. Damage in refineries is often associated with dew point corrosion, in which vapor containing what and hydrogen chloride condense from the overhead steam and distillation, fractionation, or stripping tower. So, hydrogen chloride condense. What would be there? Let's think this through. Oh, man. Dew point corrosion, I want to say H2O. C. When connected to a more anodic material, titanium may suffer hydrating. B. Hydrating is usually associated with titanium. For these questions. Is a form of stress corrosion cracking normally occurring during shutdown startups or during operation when air and moisture are present? Cracking is due to sulfur acids forming the sulfide scale, air and moisture acting on sensitized stainless steel. Oh man, that sounds like polyphenolic acid stress corrosion cracking. What blank is usually occurs when a colder liquid contacts a warmer? Thermal shock. Which of these materials is not susceptible to amine cracking? Amine cracking. I know it's probably a stainless steel. It's either both or one of these. Amine cracking. 400 series stainless steel. I say it's D. It's both. You usually should go with both. 300 series and 400 series. Carbon steel is like almost everything affects carbon steel. The presence of what in H2S streams increases the severity of high temperature sulfide corrosion at temperatures above 500 F. The presence of high temperature sulfide corrosion. Presence of sulfides. B. Hydrogen. The presence of hydrogen in H2S streams increases tide. Okay, it's hydrogen. Increased chromium content in the alloy improves resistance to sulfidation. However, there is little improvement in increasing chromium content until about, I want to say 7 to 9% chrome. C, 7 to 9 chrome. Is the sudden rapid fracture stress residual applied where the material exhibits little or no evidence of plastic deformation? That's brittle fracture. That should be in your head by now. Caustic embarrassment cracking can be effectively prevented by means of post-well heat treatment at a temperature of 1150 F. General or localized corrosion of carbon steels or other metals caused by dissolved salts, gases, organic compounds, or microbiological activity is called Mick. That's the other one that's kind of cooling water corrosion. It's easy to get those mixed up in a question like that. It's cooling water corrosion. I have to read over that section again. With CO2 corrosion, increasing temperatures blank corrosion rates up to the point where CO2 is vaporized. Increases. Units where graphitization may be suspected are the FCCU and the graphitization. I want to say Coker unit. Where is PASCC normally located? Well, I want to say it's stress risers. That would make sense. Or adjacent to welds. Let's say at stress risers. C. A. Adjacent to welds. PASCC. Normally located adjacent to welds. Where you got that, weakened metal. All what base materials and low alloy materials 300 series SS and 400 series SS are susceptible to sulfidation? Carbon-based materials. Nope. All iron-based materials and low alloy materials 300 series SS and 400 series SS. So I think sulfidization, sulfur, and iron don't mix. Sulfuric acid promotes general and localized corrosion of carbon steel. Carbon steel's heat-affected zone may experience severe corrosion. Acid concentrations, temperature, alloy content, and are critical factors affecting sulfuric acid corrosion. I almost want to say velocity of the fluid flow, acid concentration, temperature, alloy content, and I don't know. Yeah, velocity. Which of these materials are susceptible to brittle fracture? All of them. And D. Is a form of environment cracking that can initiate on the surfaces of high-strength low-alloy steels and carbon steels with highly localized zones of high hardness in the weld metal, and has, as a result of exposure to aqueous HF acid surface. A form of environmental cracking. High-strength low-alloy steels, carbon steels, highly localized zones of high hardness. Man. Oh, man. Is that hydrogen-induced cracking? I don't know. B. Hydrogen stress cracking. So, yeah, that's something I just gotta go back and memorize. HCl acid corrosion is found in several units, especially what units? Hydroprocessing units and Calac reformer units. Amine and crude units, maybe? Nope. Crude and vacuum. Crude and vacuum unit. Hydrochloric acid, crude and vacuum units. Cracking can occur at low caustic levels if concentrating mechanisms present. In such cases, caustic concentrations of what ppm are sufficient to cause cracking. Wow, I have no idea. Oh man, say 100 and 150 sounds like a good number. Oh, only 50 to 100 parts per million of caustic concentration. So not 50 and 100. Which of these materials is susceptible to 885 embrittlement? I'm just going to go with D. 400 and duplex. Yeah. Spherization and graphitization are competing mechanisms that occur at overlapping temperatures ranges. Spherization tends to occur preferentially above, and while graphitization predominates below this temperature. Oh man, I do remember reading this. I want to say 1100 F. That sounds like the range. B, no, it's 1025 F. So make a mental note. 1025 F. Separate spherization and graphitization. Sulfidation is primarily caused by blank and other reactive sulfur species as a result of the thermal decomposition of sulfur compounds at high temperatures. I want to say H2S. B, H2S. Damage from sigma phase appears in the form of sigma phase damage. Oh man, cracking. Whew. The extent and depth of decarburization is a function of temperature and decarburization. Exposure time, maybe? Corrosion of the anode may be slightly higher blank to the connection to the cathode, depending on solution conductivity. Corrosion of the anode may be significantly higher adjacent to the connection to the cathode. B, adjacent. Conditions favoring carburization include a high gas phase carbon activity and blank oxygen potential. Man, oh boy. Low oxygen potential? Susceptibility to temper embrittlement is largely determined by the presence of alloying elements, manganese, and temper embrittlement. Manganese and I want to say chromium so bad, but I don't think that's right. Let's just say chromium. Silicone. Manganese and silicone equal temper embrittlement. Improved resistance to erosion is usually achieved through increasing substrate blank using harder alloys and harder facing or face hardening substrate hardness. See? I mean, that's the only one that makes sense. So take a break.